One question that we get asked about a lot is, does this device support my language? And there's a problem with answering that because that can mean a lot of different things when you say, does it support my language? And it's really a better question is to say, well, what level does it support my language at? And so what we're going to be doing is going through a set of levels that were developed inside the CLDR committee and fleshing out what it kind of means at each level. And I want to qualify that when we say level, it's really kind of a matrix, but it's much easier to think of things sort of logically as levels with exceptions than it is to think of a matrix, because that gets too complicated for people. So I'm not going to go through these items on this slide, but as we go through them in the slides, we'll talk about them in more detail. So, and my colleague Luke Schwartz, we've been working together for many years now, and I are going to team teach this. So we're going to jump around a little bit on the podium, try not to be distracted if we keel over or something like that.
And then we also have our third colleague, Don Van Esch, who unfortunately wasn't able to join us in person due to the late expiring European travel ban, but he's graciously joined us from the Netherlands where it's a very unreasonable hour. So he'll be mostly here for the Q&A because neither of us have as much deep experience on especially the machine learning big data side that he does. So I'll start with why does this matter? And I know that like saying, hey, we should have better language technology for more languages is preaching to the choir with this audience, right? It's like telling firefighters that water is good, right? But I think it's still important to understand why, both so that we can clarify like how we prioritize our time and our effort, as well as so that when we evangelize this kind of stuff with our organizations and outside communities, we can make a good case. So as has been stated by many here, SIL Ethnologue estimates that there's roughly 7,000 languages in the world. UNESCO says more like 6,000, but it's at least that order of magnitude. And largely thanks to the efforts of the people both in this room and in the larger conference, especially Mark, Unicode now supports basic writing and coding for more or less all of those languages. There might be some small exceptions, but generally speaking, all the modern ones that are currently being used are part of Unicode. That being said, a lot of language technology is missing. So Google's Gboard is our keyboard, and largely thanks to the efforts of Don, our colleague, it now supports well over 500 languages, which is pretty impressive, but it's still an order of magnitude less than the number of languages there are in the world. And if you look at various products, like some Google products like the Google Assistant only support around 20 languages, although again, we'll discuss what it means to support. And then there's some other Google products that support somewhere between like 60 and 100, but again, it's an order of magnitude less than the languages in the world. So what are those languages? What are the languages that have less support in some technology products? Well, they tend to be, understandably, languages spoken by communities that are lower resource, right? Like the languages of the rich and the powerful tend to be very well covered, and the languages that have a lot of speakers too, right? Although again, it's sometimes difficult to say what's a language, right? Like there's, Chinese, for example, could be considered one big macro language or a lot of related dialects or separate languages, that sort of thing. But, certainly there's a lot of Mandarin speakers no matter how you slice it, right? A lot of these languages that are under-resourced are endangered as well. So UNESCO estimates that 43%, so nearly half of all the world's languages are in some way endangered. A lot of these language communities are, at least historically, in some cases today, either oppressed or marginalized. Their language might be actively suppressed by majority communities and those in power. And a lot of the time, the people that speak these languages have fewer resources. A lot of the time, they're indigenous communities. Right, so in general, there's maybe, I think, a moral imperative for us to do what we can to help these communities. And so what would it mean if we were able to help these communities with languages? So one, going back to Gretchen's keynote, she talked about the power of language, especially written informal language, to connect people in ways that they weren't connected before, right? So particularly these minoritized dialects and languages, right? There's also a level of sort of empowerment and dignity. So at Google, we have a team that's focused on novice internet users, and they are starting to focus more on the ability for technology and the ability to use technology, especially in ways that are comfortable to you, as a way of giving users dignity, right? That they don't need to go to someone else to go get help, that they can help themselves. But then it goes beyond that into equity, where it's not just about individual users' dignity, but it can be the empowerment of a whole community, right? This can, like, the right kinds of technology in the right hands can help these marginalized groups reclaim their power, right? And help maybe lead to better social change that make for more egalitarian societies. And then probably the most clear thing that language technologies can do is they could be the difference between whether a language survives or not. So I don't know how many of you got to attend Robert Mello's excellent talk yesterday about indigenous languages of Latin America, and he mentioned one thing about a child whose parents speak an indigenous language who didn't want to speak, and he said, well, it's not on my cell phone, so I don't want to speak it, right? If it's not on my cell phone, then it's not important, right? There's similar to our colleague Craig Cornelius, who's done a lot of work on various kinds of low-resource languages, told a story about how the Cherokee Nation was worried about their language disappearing because children, especially young people, couldn't send text messages or other social media to each other in the Cherokee language, right? So, I think it's important for us to, I think like many people here, I'm probably a technological optimist, but technology is morally ambiguous, right? Like technology can be an accelerant towards making these languages more extinct, but it can also help preserve and extend and help these languages stay alive, right? So I think it's incumbent on us as a community, because if there's going to be change, it's going to come from this community at this conference, right? I think it's incumbent on us to take that responsibility to do what we can to help save these languages through technology. All right, and briefly, so with that as kind of our mission, like what kinds of technology are there and why does it matter, right? So we'll kind of go through that chart that Mark showed, and we've kind of divided up into 4 very loose categories. So the first is just basic table stakes for display. The second is various kinds of content languages. We'll kind of explain what does content mean. There's UI language, and then there's kind of advanced or machine learning stuff at the very end, which is a pretty broad category and one with a lot of innovation. And then finally, we'll close with various ways that you can help. Right, and with that, I'll pass it up back to Mark.
Great, thanks, Luke. I also want to emphasize that the presence of scripts in Unicode owes a lot to people all over the world, and especially to Debbie, who's been really coordinating the work of getting scripts into Unicode for many, many years now, Debbie, yes. So we owe a great thanks to her and all of the other volunteers who have worked with people to get proposals into Unicode. Well, one of the first things that we need to look at when we talk about getting a language on a phone is just being able to select it. And so at this level, we really need to have, it's got to have a recognized language code that we know that it's got a what's called a BCP47 code. And that has to be in place, and it's got to be clear what that means. One of the key issues that we have when it comes to supporting a language on a cell phone or anyplace else is what are the predominant dialects, and of the predominant dialects, what are the predominant orthographies? Because we got to pick one. So if it came to supporting Swiss German, for example, which I'm familiar with, you could support the Zurich dialect, but then you would disappoint all the other people that spoke Bern or St. Gallen or any of the other Luzern dialect and so on and so forth. So you have to pick and choose and figure out what is the predominant dialect you're going to go for, and then you have to have an orthography for it. And in the case of Swiss German, again, there are multiple accepted orthographies, but actually none of them are what you see people type on a cell phone when they're messaging one another. So the orthography and the dialect are extremely important when it comes to picking picking, supporting a language on, say, a cell phone. We also need to know the script that it's written in, and we need to know whether there are variants that exist across countries. And this is essential for any technology, just for the basic technology of picking the language on a phone. Now, it goes without saying that you've got to have an encoding. Yeah, Marcus? Am I drifting in and out? Yeah, okay. Okay, thank you. Of course, the encoding has got to be there too. So we've got to have the characters in Unicode. Luckily, essentially all modern languages are covered by Unicode. There are some outliers that we're working on, but the vast majority of languages, at least one of their customary orthographies uses a script that's already been encoded in Unicode. And some I'd like to mention also, again, the script ad hoc group, which Debbie has been leading, and Berkeley's SEI initiative, which has been helping a great deal in getting additional scripts. This is a long lead time. I mean, it takes multiple years, especially with a complicated script, to get into Unicode. It's not something that happens tomorrow. It takes a long process to develop it, and partly because these languages tend to be under-resourced, difficult to determine how they work and so forth, it can be difficult to determine exactly how the characters work. But as I say, luckily we're in pretty good shape for the vast majority of languages. The second thing is display. If the language can't be displayed because the fonts are available, that's a huge barrier to having it on your phone. Now, luckily, the Google Noto supports essentially all of these modern living languages, and a lot of products will pick up Google's Noto font, which is open sourced, and use that for the languages that they don't have their own fonts for, which is great. And we owe a thanks to Bob for spearheading that effort some time ago to really get coverage in the Noto font for a lot of languages. However, even if the fonts are available, it can be hard to get onto devices because a lot of the phones will cut the number of fonts that they have on the phone for various reasons, or they will have phones that are built only to support a narrow set of languages. The second is rendering, and you have to have harfbuzz or its equivalent for any kind of complicated script, any script where the characters merge and meld and split and do all sorts of interesting things like Telugu or Malayalam. These get very interesting to support. So the font has to be built and the rendering system has to be built to work together to support these.
So for those of you that joined Craig's talk yesterday about, hey, what's all the stuff that comes after encoding? Largely, this is a lot of that, right? That even once if you're in this language community, you've worked hard with Debbie and her team to get, you're finally in the Unicode spec. You're like, yes, we reached the finish line. Well, no, you just reached, the old Winston Churchill quote. It's only the end of the beginning, right? That there's a very long road ahead to get the font. That we also recognize that, like the Android ecosystem in particular, it's tricky often to get fonts on there because we'll ship Google Noto, but not every OEM includes it, and that often for good reason. They're trying to, like, every megabyte counts on some of the phones that don't have much storage space, so we understand why they cut out the fonts, but every font they cut out is a language community that can't communicate, right? So largely because of this, so I'm going to say two slightly controversial things during this talk, which I don't want to attribute to Mark because I don't want to get our president embroiled in controversy unnecessarily. But the first one is that we as a community, we as the Unicode community and all that, might be inadvertently, with the best of intentions, giving communities maybe because we've been in the encoding business for so long that that's one thing that we'll jump to maybe, right? And that new scripts aren't not necessarily good for a community, right? There's this very long road, and there's a lot of incompatibilities and so forth that could result in. So I think it's important, if a community wants a new script, like I think there's an important concept, nothing for us without us, right? The indigenous people should be leading their own kind of power, right? So if a community wants a new script, I don't want to stop them, but I do think it's important for those of us that know all the steps to make help them realize the trade-offs, right? Often if it's a really new script that has no existing use already, especially no existing written literature, the downsides probably outweigh the good sides for those new scripts. All right, and with that, let's talk about content, because that's exactly the next thing. So when we talk about content, that's basically everything. Once you have that basic rendering down, what else is needed to communicate, to produce or edit documents, or maybe to search or navigate other written content for that language? So the first and most sort of fundamental, possibly, technology is input, right? So this is one that our colleague Don did a lot of work on Gboard specifically. It's one that Gretchen's keynote talk largely focused on. And there was also a great talk earlier today about how to do keyboard layouts in CLDR. So it's definitely a theme that's emerged from this conference already. At the base level, you'd absolutely need some kind of layout that makes sense for that language. But ideally, you also have things like word lists and dictionaries. So when Don and his team were building the over 500 languages for Gboard, the vast majority of them, we estimate over 90%, have at least some word lists or dictionaries, because that makes the keyboard a lot more useful, especially in the mobile context. Ideally, you also have a rich corpora, right? Because then you can use that to either develop those word lists or dictionaries. But if you have rich corpora, you can also build language models. So you can do things like swipe keyboards and so forth. There are some languages where you also need IMEs. There are some languages where transliteration really matters, especially for Indian languages. In some cases, spelling and grammar, although that gets a little bit into the later part of the talk where we talk about ML, because a lot of spelling models are now machine learning based. As Mark mentioned, though, often orthography can be a big challenge here, right? In fact, someone in an earlier talk said, the smaller the language community, sometimes the less standardized, like the more opinions there are about how things should be spelled, right? So there's sort of that paradox there. And also, like Mark mentioned Swiss German is just like the tip of an iceberg, that each one of these languages has multiple variants possibly, and so which one are you going to, you could possibly try and make keyboards for each variant, but sometimes you have to choose which one you have for the macro language and so forth. So again, we're very proud of the work we've done so far at Google with Gboard, but again, we're just kind of scratching the surface of language input, which is kind of the very first step after encoding to get good content. And then I'll pass it back to Mark.
Yeah, one of the next steps is we need to be able to select your language on a language picker. So when you start up Android and you want to pick the language that you want to use, and often the strategy is that for a relatively under-resourced language, we also require that the person select another language also. And that's because, oops, I need to step right here and stay here, right? And that's because if you're speaking Cherokee, there are going to be a lot of apps that don't support Cherokee. So even if you can pick it in the system, you always want to have a fallback. So if your system supports Breton, then you want to be able to say, well, I also speak French. So if the app doesn't support Breton, then I can get French. And so it really helps if the person can supply an additional language that, even if they're not completely comfortable with, that a range of applications will still function in, and they can use them functionally. There's other additional information that is usually required, some very simple things like what are the characters used in the language, how do I form numbers in the language, how do I form dates in the language. This sets a very low bar for what an app can depend upon in the system for how to do it. Luckily, that low bar is a fairly small number of resources, so that corresponds to the CLDR basic level. And that's a relatively small amount of data for people to supply. And unless you have, excuse me, unless you have the ability to select the language, then you're you kind of can't get off first base. So that's one of the key things. The next is, and these correspond to CLDR levels. We did a bunch of research within Google products to find out what are the levels of internationalization support and data that we need if we're going to support a language, but it's not necessarily a UI language. And what do we need for spreadsheets? If you want to have a spreadsheet in your language and have it work right, what are the sorts of features that, excuse me, you need in that? What are the sorts of features that you need to be able to write in a doc and produce a textual document with it? Things like you've got to have a line break correctly, you want to have word selection to work correctly. These are sort of basic things that you want. If you're just using, even if the UI is something different, it allows you to use your language in content, so that not only can you read something on the internet, but you can produce content in your language. And so these are typically in CLDR, there's a vetting process. We are open to people coming in, and we have some very enthusiastic language communities like Cherokee, for example, where they're purely volunteers, have organized to produce, with the help of people like Craig, to wend their way through the process to produce and keep this up to date. And an important thing is that often people don't realize that there's a steadily increasing amount of data that's needed for good internationalization. So it's not just a one-time thing. It's kind of every year we need to get continual engagement from people. For CLDR, we have roughly a 1-year lead time, and then it goes into ICU. Actually, it can be cut down depending upon where you are in the year to about 6 months. And then, of course, once it gets in ICU, it needs to get deployed. A lot of times that takes a while before that gets deployed on phones and so forth. So there's a lead time here as well. So we've got to add this lead time to the encoding lead time. And then there's full content, and full content provides a host of facilities that people want on their phones, not only just the stock dates and times, but a variety of different things. On a cell phone, you're very conscious of space, so you want to say December 3rd instead of December 3rd, 1999. You don't want to spell out everything. You need compact forms of numbers. You want to be able to say 3 million with a 3M or whatever the related version is. So this takes a lot of interesting data, and languages behave differently. If you look at many Indian languages, they use, instead of thousands, above thousands, they go by twos. So it's really important to look at I guess it's a myriad as the number, and that's the thing that you would abbreviate for 3M for 3 million instead. We also have names of languages, scripts, countries, regions, emoji, and so forth that compose the full range of information, and units. You want to be able to say this is 3 kilometers away, it's 10 feet away, and in the native language for what that is. And back to
okay, so I mentioned I was going to say a couple of things that are controversial. This is the second one, which is UI languages. And so with UI languages, it's something that often there's a lot of enthusiasm around. Hey, we're going to translate name of product into name of language, and everyone gets really excited about it. And again, like, you know, if someone wants to do it, I don't want to dissuade them, but there are a lot of trade-offs. So I'm just going to kind of state some of the lessons learned that we had at Google and why I tend to recommend, you know, beyond the set of, like, we've got somewhere between like around 80-ish languages that are pretty broadly supported in Google products as UI languages, that why I usually am skeptical about expanding that set. So one is just cost, right? That it costs money to get these things translated. and that often that there's not, like people, when we've translated into these very long tail languages, very few people actually want to change their UI into it. Lots of people want to communicate in it. Lots of people want to consume or create content in those languages, but relatively few people actually want to change their UI to it. You might say, well, okay, if it costs a lot for a professional to translate it, maybe you can just use volunteers. You can crowdsource it. And we've tried that, and with some success. But generally speaking, we've found problems with quality. Where if you get what you pay for with volunteers, understandably, they're volunteers. With latency, where Google products are coming out with features sometimes every week, and volunteers, understandably, aren't willing to give you, quick turnaround because, again, they're volunteers. Sometimes there's problems with, maybe quality control, or maybe it's like a spam and abuse problem. We've had cases where, someone was just playing a joke, but they changed the translation from something to something politically sensitive or otherwise, clearly, abusive. Sometimes it's really hard for volunteers to keep up with just the sheer quantity of strings in some products. Also, there's cases where there's a feature that hasn't launched yet that ends up leaking through this volunteer process. So, again, like we've seen success, especially with smaller projects. In fact, Google, when it got started, had this Google in Your Language initiative back when there were only a few hundred strings on Google. So it was pretty easy for a small set of volunteers to translate everything. And in fact, it's kind of hidden now, but there's even these what we call joke languages, like you can do Google and the Swedish chef. So it's, I'm feeling lucky, bork, bork, bork kind of thing, right? Because they were like, well, it's, easy enough to translate into these, kind of funny languages too. But, now there's, I don't know how many, but probably tens of thousands of strings for Google search where it's not feasible to do that with, at least not to do it well with a volunteer community. So these are all reasons why, in general, I would recommend, both internally within Google, but also for a lot of other organizations, that there may not be a huge return on investment from translating your UI into some of these longer tail languages. Now, that being said, does that mean that we stop here? So, Mark kind of mentioned that we first said these are levels, almost like maybe Maslow's hierarchy, but really, I'm going to propose that maybe in the same way that a lot of countries shifted from having more or less no electricity, or at least no telephone lines and so forth, directly to mobile smartphones, and they skipped over desktop computing and landlines and all that we did in the US. In the same way, for many of these languages, maybe it makes sense to skip directly from content language to some of the more advanced machine learning that could be transformative for these language communities, and just skip over the UI step. Now, that's not, it's easy to say, but hard to do. Like, I know at least at Google, a lot of our more advanced technologies sort of assume that you already are launched as a UI language. So a lot of this, I think, would, I'm just kind of raising this as a potential challenge and opportunity, both for Unicode as an organization and for the various organizations that we represent. That might be the best return on investment for helping out these language communities, is how can we kind of skip over UI language and go to the next step? And with that, we'll talk about advanced language technologies. So a lot of, especially at Google and really around the industry, a lot of our language technology increasingly relies on machine learning, and machine learning relies on a lot of data. So what kinds of data? So, our colleague Don van Esch, like his bread and butter right now is typically audio recordings, because he's working a lot on Google speech technologies. It's best if those audio recordings have transcriptions, although they not 100% need to have them. Having corpora, whether it's monolingual or multilingual corpora, it's really helpful for translation use cases to have parallel corpora that have the same semantic meaning. Structured data is super helpful too, from either Wikipedia or Wikidata, schema.org we use a lot. Now, one of the big challenges is that of those under-resourced languages, a lot of them aren't commonly written, and certainly aren't commonly written on the internet. So, getting these corpora, you kind of have to be more innovative. And Don has all various tricks that he's done. But by the way, I should mention, Don's written a lot of papers. So, if you want to learn about this subject, you could do a lot worse than just go on Google Scholar and look for Don's name. And he's either authored or co-authored a lot of really interesting papers, including, we'll get to Lang ID. There's some interesting stuff about how you identify languages, which is the first one here. So one of the tricky things, and this can also be used to bootstrap corpora, is how do you identify that a language is a language, right? If, given a random web page or a snippet of audio, how do I know whether that is in, Bengali or in Hausa or some other language, right? And so we have language ID models that we've developed at Google. There's a great paper that Don co-authored along with Isaac Caswell that goes into a lot of the challenges when you're dealing with longer tail languages. One of them being that there's the false positive paradox, is that even if you have a 99% accurate language ID for a long tail language, precisely because it's long tail, most of the things you identify will actually be false positives, right? Because the actual incidence in the real world is so small, at least on the web, right? So there's a lot of interesting challenges there. But once you have Lang ID, that can help you bootstrap some of these other things, especially if you already have like a corpus, but you don't know which parts of that corpus are in that language. Again, we mentioned that for speech technologies, it's super helpful to have a rich corpora of audio data, especially with transcriptions, that can help you with either automatic speech recognition, so from speech to text, basically, or text to speech, which are both super important for a number of technologies, whether it's input or voice assistants. There's some discussion around how can we make technologies that are voice first, that don't rely on the written word at all, especially for these mostly spoken languages where like maybe it's just unusual to write them at all, right? So how might we do that? Like I mentioned, translation is something that the Google Translate teams did a lot of work with neural machine translation, and they have some really interesting papers about how to leverage large languages to bootstrap smaller languages and so forth. A lot of these technologies lead up to various kinds of natural language processing. So it's something that Bob mentioned as maybe a possible thing for the Unicode board and Unicode consortium to look at going forward. Those are obviously required for various kinds of spoken assistants that various companies are developing. And then finally, there's OCR, which can help, especially if there's a written corpus. Especially a lot of the time, these written corpuses are not digitized, and one way to get them digitized is to OCR them. All right, so a few of the techniques and lessons learned. Well, Don has been through the trenches on this, so if you have questions during the Q&A, he can maybe tell some particular war stories here. But one thing we found that can be helpful is soliciting data from native speakers, right? So precisely because there's no corpora, especially on the web, in these languages, maybe we just need to go straight to the native speaker. And also, to get to Gretchen's keynote, a lot of the time the corpora that does exist tend to be very formal. It tends to be things like the Bible or the UN Declaration of Human Rights, which are great documents, but generally speaking, people do not speak in UNEs or in biblical language when they're texting their mom, right? So in order to get more natural, more informal speech, often eliciting it is the way we do it. It's still challenging for these mostly spoken languages to get this kind of data. So again, we're looking at how would we do just audio only. I kind of mentioned a little bit of bootstrapping. Early on, Google Translate was able to work create a working Yiddish translation, basically bootstrapping off of German and Hebrew, which are kind of the source languages for Yiddish. But more recently, they were able to use multilingual models like Mum and Bert to take a large multilingual corpus and then a relatively small parallel corpus and use that to bootstrap. So there's some interesting techniques there. And then I guess the larger set is either unsupervised or at least semi-supervised learning, which is kind of the next frontier of machine learning, which again can help because we're not going to have a lot of at least explicit training data in long-tail languages. All right, so briefly how you can help, and then we'll open it up to questions. So obviously, this is maybe, again, preaching to the choir, but like CLDR, ICU, and ICU for X are three technologies that will help various communities in various ways, especially for content language. So we encourage you all to contribute to that or to connect language communities with that process. Anything we can do to create or digitize corpora, including just contributing to Wikipedia in various languages, can also be very helpful. There's a number of NGOs that are doing great work in this. And then I think smart advocacy, and this is one where maybe Unicode also has a hand to play in helping language communities advocate, being an assist to help them advocate for things that will really be most impactful for their communities. And with that, we'll open it to questions.
We know by asking Debbie. And when Debbie says we're done, we're done. It is, you know, you can't prove a negative, but you can definitely go down. A lot of the scripts that are being encoded now are being encoded for preserving digital heritage. I mean, preserving our linguistic heritage into the future. So there's a lot of work being done on archaic scripts. Scripts are no longer used by living languages, but there is also looking for are there some odd scripts that we haven't covered that we didn't learn about, and in that case, those are absolutely candidates for encoding. The thing I want to stress, though, is in terms of if you focus on the bulk of the languages, the ROI is better for helping those languages get onto machines in the first place, and then keep this effort on looking at additional scripts, additional characters in scripts, and so on. Does that make sense? Yeah, actually, I wanted to mention, Luke talked about the spam issue, and I remember a particularly interesting case early, when I was early at Google, is there was a map of Crete, and Google had the ability to add in translations and so forth, and it turns out that this one little town was named something in Greek, which turned out to be just the Greek word for MacGyver. And somehow somebody got that in.
Yeah,
so
in that particular case, it was Wikipedia spam that had made its way into Google Maps.
Yeah.
Because Google Maps had flipped a bit, and instead of filtering out spam, they only let in spam. So, yeah, so that was, it ended up in the Greek press. It was many years ago, though. I think they fixed it.
Years, yeah. So, yeah. But there is a danger for that. That's a difficulty that we always have to worry about in this area, is that there is just too much opportunity. We have to be watch for the opportunities for people to produce spam.
Maybe if I can, join in with an example of how we nearly shot ourselves in the foot once. So we were working on keyboard languages, and we were working with some vendor, and we had given them a long list of languages which were, shall we say, not exactly like run-of-the-mill mainstream languages that they would work on, right? And, we don't work with those languages very often ourselves either, right? There was a situation where we had like one pidgin based on English and one pidgin based on French, and the ISO language codes were basically just one letter apart from each other. Unfortunately, the vendor swapped them around, right? It's a very easy mistake to make. We didn't notice this. So we took delivery, and we built the keyboard based on the character analysis and all of that. And this was not in any way spam. Nobody was trying to game the system, right? But it's just very hard to actually figure out what is good data when you're working, in situations where you really don't know the language. We actually only noticed this after we had built everything, and we sent it to some native speakers to check it out and see, hey, how is this working for you? And they were like, I don't know what you think you are doing, Google, but this is not our language. Like, please explain this to us because you have done this wrong, right? And then we went back and traced our steps and eventually discovered, oh, okay, one letter, juxtaposed in the language code there. We should have noticed that this one was a, obviously English-based pidgin and this one was a French-based pidgin, right? But it's very, very hard to do quality control, even when everybody is trying to do the right thing, in these settings where there are so many languages in play. So that is really, really challenging for anything, even CLDR and everything, right?
More questions?
This is probably a question for Dan, but I've heard about natural language processing, machine learning, speech processing outside of big companies. And I would like to know if there are ideas or thoughts on, will these become more useful for languages beyond what Google and Apple and Microsoft, et cetera, are willing to support?
Don, were you able to hear that?
No, not quite.
Okay,
Can you repeat it?
We'll repeat the question. Craig, you can give me a thumbs up for this. we talked a bit about natural language processing and speech technology that happens at Google and other large companies, but I think Craig had a question about what about outside of those large companies? Is there, I know one answer is, maybe, Don, you want to speak more about the Mozilla project? I forget the name now.
Right, yeah, Common Voice.
So you want to speak more about that, Don?
Yeah, sure. Yeah, I mean, there's actually an entire very rich booming field, I would say, of people building platforms and tools to build speech recognition or text to speech or translation apps outside of the sort of bigger tech companies, which I think is great because there's that many languages, and in a lot of the scenarios, it just makes sense. There's like perhaps a community that has some data already. Why should you go through all the complicated process of getting that data into the hands of a tech company with all the licensing issues that might be involved there, and everything, and then somebody else trains a model. It's much easier if it's just straightforward for anybody to train a model on the data that they already have, right? And a lot of the time there is already quite a bit of data, like maybe storybooks have been translated, or people have recorded stories, or they have audio recordings with transcriptions from linguistic fieldwork. So if you look at it, for example, there's all sorts of toolkits. Hugging Face is very popular lately, but even Google's own TensorFlow, of course, can be used. We've published recipes for machine translation. And I think especially as devices become more powerful, you'll also see that become a natural host for these models, right? So it's already the case that you can pretty straightforwardly, if you have some data in a given language, you can train a machine learning model. And if you don't have the data, you can pretty straightforwardly collect it using something like Common Voice. But currently, one bottleneck is once you've collected the data or you've sort of digitized the data that you have, and then you say, okay, now I have a model that I've trained using TensorFlow or Hugging Face or PyTorch or whatever you might have used. There's lots of these open source toolkits. Historically, one big problem has been, okay, you've got the data, you've trained the model, now you have to host it on a server, and that's actually really expensive, right? Because these machine learning models are really expensive to run. Every time somebody speaks, there was famously like some estimate once about how much machine power, how many data centers we would need if everybody on the face of the planet were to speak to Google Voice Search for even just a minute every day. It is a rather staggering number. But now, of course, with phones becoming much more powerful, you could actually see people running those models on their own phones, right? And that has lots of benefits. It's offline. So I think there's a very nice set of changes there in the last few years, and I think that'll continue. You'll see more people training their own models, like Masakane in Africa is doing, and then running them on their own phones and so on. I think that's great. I think that's exactly what we need to solve, for thousands of languages.
Other questions?
I think we're seeing stunned silence.
Well, thank you for your time and attention, and we're eager to work with all of you on helping to advance language technologies for a lot of these languages.